आया अभी इधर लाइव।
हाँ
हो रहा है
स्टूडेंट को
Okay.
5 मिनट्स टाइम डाल
तो-
के इधर।
हाँ
वो जो गो लाइव का जो लिंक आया ना,
हाँ
अभी यूट्यूब चालू है ना आपके इसमें?
हाँ
यूट्यूब चालू है ना?
हाँ यूट्यूब चालू है।
हाँ, उसका जो लिंक कॉपी करके काइट पे डाल दो।
किस में डालो?
ये टेलीग्राम में 5 मिनट्स डालू क्या?
नहीं, अभी एडमिट करते हैं सबको।
करूँ?
हाँ, कर दो एडमिट सब।
करना चालू करूँ?
हाँ हाँ हेलो हेलो
हेलो।
हाँ।
यूट्यूब का लिंक क्या ने कहा?
नहीं, मैं करता हूँ। आप कुछ मत करो, मैं करता हूँ।
विनर
हाँ,
वो कॉपी करके
मैं करता हूँ।
Okay.
आप मत करो। चालू कर दो।
हाँ चालू है।
और एडमिट करते सबको।
हाँ
मैं करता हूँ। चार्जिंग लगाओ जल्दी आओ। Zoom लिंक सेम है ना अपना वही?
चलो अभी लाइव है, अभी स्टार्ट ना।
हाँ
को होस्ट नहीं दिखा रहा है रे, पार्टिसिपेंट मुझे पेंडिंग इसमें नहीं दिखा रहे।
होस्ट दिखा रहे ना। एडमिट करता हूँ विनर स्टूडेंट को।
यस, तुषार को भी को होस्ट बना दो।
हाँ हाँ वही सेम है।
हाँ मैं करता हूँ।
बनाया
चलो स्टार्ट करते हैं।
स्टार्ट करते हैं क्यों?
यस, टेली सर इज लाइन ऑनलाइन।
ओके चालू करूँ?
टेली सर आ गया ना?
हाँ तेरी सर।
ओके, यस।
हाँ हेलो
यस,
चालू करो।
यस सर।
Good morning everyone. I Sundar Karvi on behalf of EXTC department from St. John College of Engineering and Management welcome you all for the third day of webinar series, the Industry Automation. Let me take this opportunity to introduce today's speaker, Dr. S.N. Teli. Dr. S.N. Teli is presently working as professor with Bharati Vidyapita College of Engineering, Navi Mumbai. He is having 23 years of teaching experience, 6 years as HODs and 3 years as a dean and 1 year as in-charge principal. He obtained PhD in 2017 from VTU Belgaum, Karnataka with Best Thesis Award and MTech and BTech with the gold medal. He is having 124 research articles published in the referred journals international and national conference and more than 300 citation and 200 book published. He hold a technical session chair for international conference at IIM Tiruchi, NITIE Mumbai, and SPJ in Mumbai, Amity University Mumbai, etc. He is having more than 50 invited talk delivered on IPR, Industry 4.0, Mechatronics, Control System. More than 30 PhDs, PG student project guided. Is an outstanding contribution in academic and research given by the CEMS, Government of India, Mumbai, September 2019, in occasion of Teachers' Day. I request Sir to start the session on uh, PLC and its applications. So we welcome you, sir.
Okay, thank you once again, Ronald sir, for giving me a nice introduction. This is the second day. Yesterday, we have seen the pneumatics, the entire pneumatics. And in pneumatics, we have seen the automation also, automatically how the systems are working. A plus, A minus, B plus, B minus. Today, we'll see the electro-pneumatics and PLC programming. Okay, first of all, I'll apologize behalf of St. John College as well as myself due to some technical issue. It has started by half an hour late. I really appreciate your patience. Okay, fine. So now I'll start software directly. Same Fluid Sim, Festo software. Fluid Sim Festo software. You can freely download from the website the Fluid Sim. Just you give the Fluid Sim and Festo, Festo. It is a German company. Okay, fine. Relay, yesterday I have talked about relay, how the relay is working. Relay is a very key component in the electro-pneumatics. So I'll take a bulb. Yesterday, a lot of piston and cylinder I have taken for electronics instrumentation and electrical student. So in perspective of these students, I'll take a bulb. This is a bulb. So how to on and off the bulb by using switch. So I'll start with basics. 24 volt DC is required. I'm using DC voltage and 0 volt. This is the bulb and bulb is the output. So that for output, the 0 volt and the ground is required. The switch, I'll talk about, there are two types of the switch. One is a toggle switch or a determinant switch. And one more is what? A push button or a spring return switch. First of all, if I use a determinant switch, suppose. So determinant switch is nothing but normal hour switch, whatever in the house we are using, that switch, the determinant switch. Here, you have to see, I'll use two circuits here now. What is the difference between spring return and push button? Suppose I'll use, this is the push button. This is a symbol. Just you see the symbol. Here there is a slight, there is a triangular shape or a notch that is called determinant switch. But here there is no any notch, dotted line. It means that it is a push button. So what is the difference between these two? Just you see that 24 volt and here 0 volt. I'll start the animation. If I press this, the bulb is on. If I make off, bulb is off. If bulb is on. This is a determinant switch, means you apply 2 times force or energy or effort, whatever. But sometimes, push button you are using, if you leave it, it will be off. This is called spring return or push button. Okay, so from this you will come to know that the how to on and off the bulb by using dependent switch and by using push button. In push button, if you leave it, it is off automatically. Means if you want to on any instrument for a fraction of second, then it is better for a fraction of second, okay, or a second, whatever. Here, how to, this is the direct method. This is the direct method. How to on this bulb by using relay. How to on this by using relay. What I'll do here, first I'll use a relay. The symbol of relay is a rectangular box. This is a rectangle box. This is a relay. You can give any name, K or R or something. Suppose I can give K. You can give any name. Then the logical switch I have to develop, because I have to take output of this. I'll take output of this relay. So what do I do? Here there is an option. Here there is an option that is a make a switch. You see here the switches are there. Here general switch, heading is switch, under switch, okay, general switch, the make a switch. The make a switch means I can take a input 24 volt, but it should work under K. So I'll type K. Now the output is a bulb. Once again, the output is bulb, indicator light. This is called indicator light. Now I am controlling this indicator light by using relay, K and K. Now you see here, if I press this, now relay is on. The arrow symbol, you have to see that it is on. This is on. So automatically this is on and this is on. And if I make it off, immediately this relay K is off. The logical switch is off and this is also off. This is how you are using a relay. Here also, I can use a relay here also. But yesterday I have talked about the latching circuit. Okay, so how the latching circuit works. Here, what is the disadvantage here? Just you see that, all of you. Here, the push button now. I'll use a push button. For example, I'll control through relay once again. Relay. Okay. So in the library, you can see that below he has written, they have written relay. Okay. It is easily understanding. So here I can give R instead of K, I can give R, K, and make a switch. So you go to switch and make a switch. And in this case, that is R. Then that is what? Indicator light. Indicator light. Okay. Here, if I start this, okay, relay is on, the relay switch is on, and the bulb is on. If as soon as I leave, it is off. But even if I leave it, the bulb should not go off. What do I do? So I'll go for latching. I go for latching. Even if I start for a fraction of a second, so it should not off. So that I'll make a switch here parallel. Then I'll write here R, because here R. So when this R is on, this is also on, and it is taking a 24 volt, and now the bulb is not off. Just you see here, even this is called latching. But problem is how to make it off. Even it is on and it remains on, how to make it off? What do? You take one more switch, the normally closed. Here you take one more switch, the specially push button, and normally closed. So this is a difference between normally open and normally closed. And this is which button? This is called stop button. This is called how to stop this. So this is called stop switch or off switch if you want to off. Okay. And this is an on switch. So here this is a on switch. Now you see here on remains on, even this is off, but still this is on. But if I make it off, if I press it, the entire thing is off. Once again I want to start, you start from here. And once again, if you want to off, this is off. This is the latching circuit. I hope you understood the latching circuit. Fine. Now, same bulb, how to use suppose on delay timer. I'll use an on delay timer. My objective is to make a one on delay timer circuit, on delay timer. In an on delay timer, the bulb should on after 5 seconds. Suppose I'll use a dependent switch and 24 volt, and that is on delay relay. On delay relay, I have to use on delay relay. Here, that is what on delay relay. This is the delay time. This is the on delay relay. So here I can set the time. How much delay you want? Do you want 5 seconds or do you want 10 seconds? Depends. You can set any time. First you write a name, suppose R or a K or any A, B, C, D, any naming, and you set a delay now 5 seconds, you can set 4 seconds. After 4 seconds, this relay is on. Then you take an output of relay by using this switch. Make a switch, output of relay R, and then you connect this output of this, automatically this symbol comes because it shows that this is the output of timer. This output of timer, and you are connecting to the indicator light. Now you see that even the switch is on, but the bulb will on after 4 seconds. Even switch is on, the timer is on. After 4 seconds, the bulb will be on. But while off, if I want to make off, immediately it will off because it's an on delay timer. You can set both the side on and off delay. So once again, I'll show when you press the switch, it will on after 4 seconds. Why? Because you have set a 4 second. You can set a 3 second also. You can set a 3 second. It will on after 3 seconds. But while off, it will off immediately. So this is how the on delay timer works. So we'll go for off delay timer instead of on delay. We'll go for off delay timer. Here he has mentioned relay with switch off delay. So the symbol slightly varies. The symbol, this is off delay timer, and I can give a name R or K somehow. So suppose I can give 4 seconds. Now, as soon as I'll on, the bulb is on. But as soon as I'll off the bulb will off after 4 seconds. So now you see that bulb is on. But when I'll make a off, bulb is not off immediately. Bulb will off after 4 seconds. This is how off delay timer works. Okay, once again, as soon as I'll on, because it is off delay, immediately it is on. But when I make a off, then it will off after how many seconds? Preset 4 seconds I have set. 4 seconds. It will off after 4 seconds. So you see that here, in a electro pneumatics or in a electrical, the actual relay, actual timer is required, hardware is required. But in the PLC, the free and soft relays are available, soft timers are available. That is the main advantage of PLC. Okay. Now you can set the time also. You can change 2 seconds, double click 2 seconds. After 2 seconds, so as soon as I'll off, suppose I want to make off, but it will off after 2 seconds. You see here. Okay, fine. So now the on delay, off delay timer, I'll how to interface this electro pneumatics or electrical ladder circuits to our pneumatic circuit. Suppose this is the 5x2 wall, and this is the double acting cylinder. This is a double acting cylinder, and the compressor is required. Compressor is required. Okay, muffler. Here the solenoid wall is required. This is symbol of solenoid wall. The solenoid wall is required. Here there is a inside there is a spring. Here also inside there is a spring. There is a electromagnetic force will develop. Electromagnetic force will develop. Suppose say I'll call A plus extend. F piston is extending. A minus. There are two solenoid. And here I'll put the sensor actuating labels. Say S1, say S2. Now I am not using a pneumatic sensors. I am using what? Proximity sensor or magnetic sensor, or it is called a reed sensor. So beginning and at the end of the stroke. So I keep two sensors S1 and S2. These are called proximity sensor or magnetic sensor because the piston is magnetic. Already the piston is magnetic, so that the piston is magnetic, so that the S1 and S2 can sense the sensors. Now, how to go for this? This is a pure pneumatic circuit, but how to draw a or how to design a electro-pneumatic, especially the electric circuit that should work. Okay, 24 volt, 0 volt. There are two parts. The first one is a pneumatic and second one is a electric circuit. So here make a switch. Now sensor S1, when S1 is on, then solenoid A plus should on. Solenoid A plus, this is a symbol of solenoid, wall solenoid. So this is a electro pneumatic valve. So this is called A plus. When S1 is on, already it has closed. Why it has closed? Arrow mark comes automatically here because already S1 is sensing here. So that there is a arrow mark, the switch has closed automatically. Means indirectly A plus is now on. And one more, make a switch here. And here this is S2 and this is the wall solenoid. This is what? A minus. This is, otherwise if you not give a naming here A minus, it is not working. Just to see that the piston is moving forward, but it is not coming back because you are not given anything here. So I'll give here A minus. Same name you have to give, A plus, otherwise Y1, Y1, Y2, Y2. So here I'll go for less flow. You can understand better. So this is the electro-pneumatic circuit. This is electric pneumatic, this is electrical. Electric logic, because logic you are given when S1 is on, A plus is on, when S2 is on, A minus is on. Only you take care when A plus is on, A minus should be off. When A minus is on, A plus should be off. And when the piston moving forward, automatically the S1 loses the contact, automatically S1 will be off. Just you see that how automatically it is working. This electro-pneumatic automation. Without relay I have used, with relay also you can use. With relay also you can use. Suppose I want to use a timer. So when it goes to S2, it has to stop for 3 seconds because some drilling operation, some punching operation, some soldering operation, any operation. What do I do? My objective is, I'll write a question. You can understand in a better manner. The question is, my problem definition is A plus, then delay delay 4 seconds or 5 seconds, delay 5 seconds, then A minus. This is the logical way, because for some operation. So A plus, okay, when S1 is there, A plus. When it goes to S2, then immediately not S1. What do I do? The timer, on delay timer. I have to use a on delay timer. I have to use a on delay timer. So when it goes to S2, the timer has to start with 5 seconds. Say timer T or a T1, whatever. Suppose T1 or T, okay, or Y1, whatever you can give a name. When the timer gives the output after 5 seconds, and when the timer starts when it reaches to S2. So now what do? I'll make a switch here. So this is the T1. This is the output of the timer. T1 is the output of the timer. I'll give to where? Wall solenoid S2. The wall solenoid A minus should on after 5 seconds. After 5 seconds. So this is the A minus. Now you see how this system works with on delay timer. You see the question A plus, delay 5 seconds, A minus. So now it goes to S2, it stops for 5 seconds. You see the beauty of the electro-pneumatic. Only pneumatic means there's a very hard, very lengthy process. Electro-pneumatic, okay, only you change the timers and all, it is good. But if you go to PLC, so many things you can add. So it is a easy, PLC is easier than electro-pneumatics and pneumatics. Suppose I want to give one more timer at the beginning also, at the S1 also. So here, what do I do? Here, instead of this, I'll give one more timer here, hardware timer. But in PLC, the software and free timers are available. But here, the actual say, for example, this is a T1 first timer, and second is 3 seconds, suppose, for example, and make a switch. Make a switch, and that is a T1. And here, there is a solenoid wall. There is a solenoid wall. This is what A plus. Now I have kept the timer both the sides, but what mistake I have done here? It already T1 I have given name T1, so it should be what different than T1. So I'll go for T2. T2. Okay. Now timer is at the both the sides. Just you observe here. It delays for 3 seconds first, then 5 seconds, then once again 3 seconds, and once again 5 seconds. Like this, it works. Okay. Now, how to use a counter? Next is, suppose when my question, I'll change my question. I'll change my question here. 4 times, suppose 4 times A plus and A minus. 4 times A plus and A minus, and cycle will continue for n cycle. 4 is, okay, I'll delete once again, then only you can understand. Okay. So this is a question 4 times A plus A minus means then it has to some delay. After this, there is a delay. Then continue for n cycle. So I'll show how the counter is working, because counter, this is the symbol of counter. So the first one is to count, second one is for reset. Okay. So first I'll go for 24 volt. 24 volt. and 0 volt. My first objective is when S1 is on, make a switch. When S1 is on, then wall solenoid. When S1 is on, what? The A plus is on. Correct. A plus is on. Next, when it goes to S2, the counter has to count. You have attached the counter. When it goes to S2, make a switch. When it goes to S2, the first you attach the counter. Counter has to take a signal. It has to take a signal and give the name of this counter, say C. Okay. And you can give a 4 counts, 3 as per your wish, then 0 volt, because counter is also output, like timer is also output. This is a reset. I'll explain later. Reset. Then when it goes to S2, the piston goes to S2, the counter has to take a signal as well as A minus has to work. So one more task, when it reaches to S2, the one more task is A minus, wall solenoid. That is A minus. Okay, I'll show the partial circuit first, then I'll complete the circuit as per the question. So just you see that 1, what happened? The count now is 3. Now count is 2. Now count is 1. Now count is 0. But it is not stopped. The count is after the counting 4. Now it has to stop. What I do here now, it has to break. I'll use a 1 switch. After 4 count, it has to break, means it should not give a supply to A plus. So that normally closed. There is called break switch. In a same make a switch, break switch. I'll use in the break switch. The name is C counter. After 4 count, the piston has to stop here. Means you should not give any supply to A plus after 4. 1, 2. When it comes to S2, you have to count 3, then 4. After 4, this switch will be CC. Your counter is on, so that this switch is open, breaks, so that it stops. But how to start once again? So there is a reset button. So reset, there are 2 types. Manually I can apply 0 volt. You have to give here reset. When you give a reset, the counter will be what? Sets to 0, automatically it closes. So that I use a push button here. This is manually resetting. Otherwise by leg paddle, there is a paddle. This is a reset button. Just you see that 1, 2, 3, 4. It stops. Now if I just apply the reset and I have to leave it, then only it counts. Otherwise the counter will be dead. Otherwise counter will be dead. Now okay, I'll give a counter is now 3, and once again I'll show, but 1, 2. How to start? By using reset. Just you reset and leave it. So that spring return button I have used. But suppose automatically this reset also, suppose you will give some 3 seconds. If you mention in the question is 3 seconds, means you set automatically. Instead of operating manually, now you have to give automatically 3 seconds. Within 3 seconds, you can remove the part, you can attach the part. So that one more timer I'll use when the
सीटे मैंने ना अनम्यूट किया और आवाज क्यों नहीं आ रहा है देखना.
now it is after when the counter starts, one more timer has to start, on delay timer has to start. Okay, this is an on delay timer, and name of this timer may be T. And here when the timer after 3 seconds, when it is on, I'll reset automatically by using make a switch. This switch, I'll take the output, input to this switch is output of the timer T. Now everything is automatic. So you have to see that the question is slightly, I'll change the question is now 3. Two and 3. It stops for how many seconds? 3 seconds, because I set a 3 second. I can set 4 second here. It stops for 4 second. 1, 2, 3, and after 3, 4 seconds. So like this, you can interlock both counters and timers also. Here, this timer has started after the counter is on, but when the timer starts, it offs the counter. Okay, so both the timer and counter are working together. This is the fine. Now I'll go to what? 2 cylinders instead of 1 cylinder. Okay. So suppose my question, I'll slightly change my question. A plus, then B plus, then delay, then AB minus at a time. Suppose AB minus at a time. Suppose delay maybe you will give 4 seconds. This is my question. Okay. So now A plus B plus means 2 piston and cylinders are required. Fine. So here I'll change the sensor. Already I used S1 and S2. Now I am using S3 and S4. And here A plus I used, so that I have to use what? B plus, then B minus. Okay. Now I'll design an electric circuit for these 2 cylinder, and this sequence is required. This logic is required. So 24 volt here, 0 volt here, then make a switch. When it is at S1, the solenoid wall A plus is required. This is A plus, solenoid wall S1, switch S1 or a sensor S1. When it goes to S2, you see the logic. When it goes to S2, then B plus, you see here in the sequence A plus, B plus. When it first piston goes to S2, now you have to write what? B plus. B plus. When it goes to B plus, there is a delay. Timer has to start. So when it reaches to S2, one more event should occur, or timer has to start. So when it is S2, the on delay timer has to start. Say T, and with the timer delay is 4 seconds. You can set the 5 second also, 6 second also, no issue. 4 second. And after 4 seconds, the timer is on. After 4 seconds, the timer is on. So you take output from the timer. The name is T. Now, when the timer is on, both A minus as well as B minus has to on. Means both the pistons retract. So I'll give the solenoid valve the connection to the both the solenoid valve at a time, because in the bracket he has mentioned in the bracket A and slightly the question is like this: AB minus means in the bracket means at a time. So this is for A minus and this is for B minus. Okay, so I can give like this. It is working. Now 0 volt. If you not give a 0 volt here below, it is not working. Okay, circuit has to close. Now this is a complete circuit for A plus B plus, delay 4 seconds, then AB minus at a time. Just you see that A plus B plus, then 4 second delay, both AB minus at a time. Then A plus B plus, 4 second delay, AB minus. Otherwise, it has started before this. You can give one more when it is at S3. When it completes here, when it is at the S3, it has to start in the AND circuit. You can give one more condition. Not only the A plus is on at the S1 and at S3 also. You can give at S3, then it first is A plus, B plus, comes at a time, then it starts. Okay, so I hope you understood how the timers and how the logic that is called sequencing. You can give any sequence. This is a electro pneumatic. You can go for 3-cylinder, 4-cylinder. Okay. Fine. Suppose I'll show one 3-cylinder. Already I made a program and I have saved. I'll show the 3-cylinder problem, electropneumatics. Suppose this cylinder open. Okay, this is a circuit. The question is first 2 cylinders A and B. 2 cylinders or 2 pistons has to extend simultaneously. Then first cylinder has to come back, A minus. Then third cylinder has to extend. Then third cylinder has to come back. Then seconds, any sequence you can develop. Same by using same basics. Okay, you see here. Okay, I hope you understood the electropneumatics. Now I'll move to the PLC programming. Okay, fine. Now I'll move to PLC programming. First, I'll take a basics of PLC programming. Within a 5 minutes, just I'll cover a theory of what is meant by PLC. Okay. So what are the main parts of programmable logic controller? So a lot of advantage compared to pneumatics and electro-pneumatics. You nowadays the cost of PLC is 10,000. Even at 5,000 also you will available up to more than 1 crore, 2 crore, depends upon the number of inputs and number of outputs. Suppose the PLC which are using Reliance company, suppose the inputs are 1,000, outputs are 500, then 1,000 some slots are required, 1,000 slots are required. This is the very big PLC. In a PLC, this is a mini computer. Actually, the PLC is nothing but mini computer. You can interface with the computer. Otherwise, you can program at the PLC only. The input model and a power supply is required, 24 volt DC. Then central processing unit, memory, then output model. So output may be the motor, output may be DC motor or AC motor or stepper motor. Our output is a piston and cylinder, a solenoid valve. Output is to the solenoid valve, and through solenoid valve you can control the piston and cylinder motion. The output may be anything. Bulb output may be okay. You can give to the washing machine. You can give to the traffic signal control. You can give any device. So here there are a lot of optical isolation, and here the 5 types of isolations are available. Programming, 5 types of programmings. Out of that, the ladder is a very powerful and easily understanding and powerful programming is a ladder. Okay. And advantage of PLC, the PLC originated in the late 1960s. Whatever the technology we are using now, it is too late actually. So in the automotive industry in the USA, and we're designed to replace the relay logic systems, because relay, the lot of circuits are required, the size is required more, and suppose 2 timers are required, means 2 actual hardware timers are required. Suppose 5 timers are required, 5. But in the PLC, all are free. Timers and counters are free. You can use 1,000 timers, 1,000 relays and all. So manufacturer of the PLC, ABB, General Electrical, Mitsubishi, Motorola, Omron, Panasonic, Rockwell Automation, Schindler Electric, Siemens, Rockwell Automation. So many companies, main companies I have mentioned. At least you will get 100 companies in the Google. And now Indian companies also manufacturing PLC. A programmable logic controller, or a PLC for a short, is simply a special computer device used for industrial control systems. They are used in many industries such as oil refineries, manufacturing lines, conveyor systems, and so on. Wherever there is a need to control the device, the PLC provides a flexible way to softwire the components together. The main advantage of the PLC are they are cost effective. The cost is very, very less. And they are flexible, reliable, and compact. Even in a small size, suppose 10 inputs or 10 outputs are required, means what? 1 feet by half feet, and height is also half feet. In this case, you can control 10 input and 10 outputs. They are significant advantage over traditional control systems based on relay or pneumatics. You have seen now the pneumatics, so many valves are required, in a relay also. But here in a very simplified manner, we can write the program. And this is the PLC ladder. I'll talk about ladder programming PLC. And so for example, draw a PLC ladder for OR logic, S1 and S2. If S1 is on, bulb B is on. If S2 is on, B. It looks like a ladder, so that it is called a ladder programming. This is called rung. This is called rung 1, rung 2. This is called rail 1, rail 2. The logic is the 24 volt is here, 0 volt is here. The current is flowing from left hand rail to right hand rail. So this side inputs and this sides are output. So here there is a OR logic here, and when S1 and S2 both are on, then only the bulb is on. And the latching I have explained there in the latching, when S1 is on, B is on. When the logic switch, here there is a logic switch, soft switch. When B, this is also on. Even S1 is off, the current is flowing from B, then bulb is on. But when you press S2, the bulb is off. Once again you start, then you press S1. This is the latching PLC ladder for latching. Okay, the piston and cylinder, once again, when it is S1, A plus, within 2 lines, you can complete the programming of A plus and A minus. Okay, A minus means the piston is retracting. So here, I used the latching circuit here, and here on delay timer. When S1 is on, lubricant pump is on, but when S1 is on, timer is also on. After 3 seconds or 4 seconds, the grinding machine will on. This is the way. The timer is also output, the pump is also output, grinding machine is also outputs are this side, inputs are this side. Okay, off delay timer, then retentive timer, then A plus delay A minus, A plus delay A minus. When it goes to S2, there's a delay. Then A plus B plus delay 10 seconds, AB minus at a time. A plus B plus delay A minus B minus. Okay, like this, A plus B minus A minus. You can use any logic. Okay, not only piston and cylinder, you can go for tank. How to maintain automatic minimum level. Here minimum level of water should be S1, maximum level should be S2. There should not be overflow of water. There should not be the shortage of water by using a PLC. And here also there is what minimum and maximum level. And here the mixing of two liquids automatically, the first liquid, second liquid, then when it reaches to S2, then both the walls, both the pump should off automatically. The fan has to start for stirring operation for a particular time, 10 seconds, 20 seconds, then fan has to stop, then discharge has to start. When at the S1, the discharge has to close, then once again the pump will start. So like this, you can write a PLC programming for any kind of applications, and especially for this is for uh, liquid bottle filling, Coca-Cola, for example. Automatically the water is filling, and it is also counting also. The high speed counters are there per second, 1,000 counts per second, 1,000 counts. It can catch the sensor. Okay, so this is what the PLC ladder programming for count 100 bottles and stops the conveyor belt for 10 seconds and starts the cycle automatically. Like this, we can write any program. This is called stamping process, stamping automatic process and all. So we'll go to the software and HL, we'll see the HL, how the PLC is working. Okay. Before this, if you want a one small 2 minutes video, has a break in between, so that you can see. Yesterday I showed the one video, and one more video is left, only 2 or 3 minutes. Okay, small video.
We are not here for the degree. We are from the international program. Oh, okay. So work it on. Oh, cool. My brother spent some time in Brazil. But all of it was unpaid. All of it was unpaid. बोल देना मैं नहीं जाना है।
Okay. Now I'll start a PLC programming. So this is a black box. The PLC is a black box here. This is called a PLC. The PLC needs, you see here I1, I2, I3, I4, I5, I6, I7, I8, the inputs. In some company, they will write I0, I1, I2, I3, I4, I5, I6, I7 like. Is standard way. The Q1 is the output. A Q0 or a Q1, Q1, Q2, Q3, Q4, Q5, Q7, Q8. Here, the 8 inputs are there, 8 outputs are there. Out of that, you can use any inputs, 2 inputs and 2 output, whatever. So he has mentioned, they have mentioned 24 volt and 0 volt. To start a PLC, first you give a supply, that is a DC supply, 24 volt and 0 volt. Okay, so I'll use a simple switch because I'll come to know how the PLC works. So here I'll use a switch, for example, dependent switch or whatever the small switch I'll use. So this is a switch. And here there is a 24 volt. I'll give a supply 24 volt to this switch. This is an input. The switch or a sensor is an input. And this is a controller. The output is, say, once again, I'll take an indicator lamp that is called bulb indicator lamp, the output side. So I can use first output or second output, Q1, and 0 volt is required to complete the circuit. But whenever I'll start this, it is not working. Why it is not working? Because you have not given any knowledge, any information, any instructions, set of instruction to PLC. Even I'll start this, the output, it is not giving any output. So I'll write a ladder programming or a FBD, functional block diagram. Functional block diagrams are nothing but and, or, not, logic. Okay, so I'll double click here. This is called a ladder programming. But in this is a free downloaded software, so that he has given only FBD, functional block diagram. Okay, so my condition, when I1 is there, I1 means what? Just you see here, I1. When I1 is on, the Q1 should on. When I1 is on, Q1 should on. Now you go for animation. When I1 is on, the bulb is on, Q1. When I1 is off, Q1 is off. When I1 is on, Q1 is on. Okay. So now, suppose I want a on delay timer. Even when I1 is on, but the bulb should on after 4 seconds. So in between, I'll use a timer. So here, the digital technique, the heading is digital technique. The digital technique PLC is there, and on delay timer is there. So you go and see here, there is called off delay, and then on off delay, and here mentioned on delay. So we'll take a on delay timer here. Any here free available. There in the electro-pneumatics, you have to purchase hardware here, and you can set a time now 3 seconds. You can set a 4 second. Okay. Now come to the animation. The bulb will on, or the indicator lamp will on after 4 seconds. After 4 seconds, just you see here. Whenever I'll make it off, it has to off immediately. It has to off immediately. But whenever I'll make on, the on delay timer I have set so that after 4 seconds. So this is the how the PLC works. After 4 seconds, the bulb is on. Whenever I'll make off, it is off. Suppose off delay, I can use instead of on delay, just I'll change in the program in the computer. There is a cable from computer to PLC. You have to download the second program. The first program will erase automatically. Okay, so off delay timer, here there is an off delay timer. And here there are two inputs. You will be confused. You would confuse, may I give 1 or 2? So there's always pulse. For a pulse, that is 1 pulse. Otherwise, you have to check. Otherwise, you have to check here also animation. There is a on. Okay, when off, it will off after 3 seconds. Otherwise, by mistake, if I given, you would have given the connection here. You have to check. Now output is off, means this connection is wrong. This is for reset actually, below line. So I'll give above. The question is, as soon as I'll start a switch, the bulb is on, but as soon as I'll off the switch, the bulb will off after 3 seconds. As soon as I'll start, the bulb is on. Okay, my logic is right. As soon as I'll off the bulb, immediately the bulb should not off, but the bulb will off after 3 seconds. Why 3 seconds? I have said 3 seconds. Just you see here. It will off after 3 seconds. This is called off delay timer. You are used the off delay timer. Okay, like this, the PLC works. Now I'll show how to attach this piston and cylinder to this PLC. How to interface the. Okay. Now this is the PLC. I'll take a piston and cylinder. Double acting cylinder and 5x2 wall. Solenoid wall is required. That is A plus. This is A minus. You can give Y1, Y2 also. And there's a compressor is required. Power pack is required. Okay. There's a compressor. And here you have to put a sensor S1. S2 magnetic sensors or a read sensor, 100. Now you come to the PLC. So PLC actually hardwire you bring a S1 sensor, make a switch, otherwise actual sensor. Here there is a magnetic sensor S1, the inside part of S1. You can see S1 and S1. So 24 volt and 0 volt is required. The output to the PLC. So 24 volt for a sensor, 0 volt, then output of a sensor to the input of a PLC. S1, this is also S1. And now you have to give one more sensor. You have to attach one more sensor, that is S2. One more magnetic sensor. The name of the sensor is S2, the inside part of S2. Here also you give 24 volt and 0 volt. The output of this sensor to input of a PLC, second input, S2. This is S1 and this is S2. The output are solenoid valves. The solenoid valve A plus, solenoid valve A minus. It's A plus, A minus. You have to give A plus, here A minus. Then 0 volt is required. Otherwise you don't give, it is not working. Actually I'll show to you. You don't give. And here you have not written any program. Here why S1 is on? Because already S1, it is sensing S1. S1 is on. The PLC is taking an input from S1. But it is not giving any output because we have not written any program. So we'll write a program. When S1 is on, Q1 is on, or when S1 is on, A plus should on. When S2 is on, A minus should on. Okay, but still there is a problem in the hardware. There is a, because 0 volt you have not given. So you have to give a 0 volt, then the complete circuit, definitely this system now works by using PLC. Okay, I'll control the flow. Instead of 1000, I'll go for 1 liter per minute. So definitely the velocity will be decreasing. You see here when the S1 is giving a signal to PLC, when the S1, what signal they are giving? 24 volt. The signal means what? 24 volt. If they are not giving any signal means what? 0 volt. Okay. Now I'll go for what delay. So at S1, when it goes to S2, there's a delay on delay. For example, on delay timer, for example, 3 seconds, or it may be 4 seconds. Suppose I'll give a delay is 4 seconds. Now, when it reaches to S2, it has to stop for 4 seconds. What are the advantage of PLC? Here, you can give any soft timers, 1000. No need to purchase any. Once you purchase a PLC, that is sufficient. It stops 4 seconds. After 4 seconds, A minus is on. Suppose I want to give one more timer here at the beginning, also 2 seconds. Suppose one more on delay timer. Free timers are available, and I'll set a time 2 seconds. 4 seconds here. Then 2 seconds at S1. So like this, you can attach any n number of timers also. Otherwise, here If you want to simplify this, instead of showing S1 and S2 detail, once you know that, I can use a very simplified circuit, make a switch. So the switch S1, make a switch. Here there is a general switch, make a switch S1, and make a switch S2. This also fine. But actual hardware, it is not actual hardware. Initial beginning I have showed. So this also works. S1 and S2, make a switch. Okay, so quickly you will go for 2 piston and cylinders instead of 1 with some conditions. Sequencing, suppose I'll use 2 piston and cylinders, and I'll give S3 and S4 0 0. So here S1 and S2, and here to make a switch S3, to make a switch S4, S3 and S4. And here 2 more solenoid valves are required. Okay, but you write a program. This is B plus, this is B minus, 4 solenoid valve, 4 outputs, Q1, Q2, Q3, Q4, I1, I2, I3, I4 are the inputs. The magnetic sensors will write a programming. When S1, Q1 means A plus. When S2, B plus. B plus means third input. When S4, both at a time, A plus, suppose, both at a time. Now, my question is, text, my question is A plus, then B plus, then AB minus at a time. This is my logic. Okay, this is my logic. Now, you see here, both will go at a time. My logic has now failed because A plus, then B plus. So you have to troubleshoot. You have to find the error, where the error is. So in the programming, basically in the programming, you go to the error A plus when it reaches to S2, when it reaches to S2, then B plus, where I make a mistake. Here I have made a mistake. There is a B plus because already A plus I have given. This is a B plus, then B minus. Okay. Now you see here, first A plus, B plus, AB minus at a time. Okay, like this, I can interface the PLC. The programming in the PLCs, you see that very simple programming, very simple programming. Now, what do I do? Oh, I'll show some. PLC counter. Even latching also. Here you see here, suppose it is a bulb. Okay. So what is the logic here? This is the on button. When I press on switch, the bulb has to on. And even when I make a switch is off, but still bulb should on because it's a latching circuit. So you see here, if I on, okay, bulb is on. If I make it off, but still bulb is will not off. You see here, why? The latching. And how to make off? This is off. Okay, while on, once again you start this. Even on button is off. Basically, where you are using, suppose if it is that it is not a determinant switch, it is a push button switch, still the bulb should on, so that I'll use the push button switch. Just to see that it is on off. It is off now, still bulb is off on. Whenever you are using a push button, the latching is compulsory. So you see the programming. The programming, it is not a ladder, it is a FBD, functional block diagram. I have converted a ladder into functional block diagram. Here, you can see the animation. The output is on, but when the input is off, still output is on. But whenever I'll make it off, output is off. This I2 is the off button, I1 is the on button. Because off button should be. Okay. So like this, this limitation of this software is you cannot write a ladder programming to convert ladder programming into FBD, functional block diagram. And one more, PLC counter. Okay. So my question is same. Already I showed in the electrical circuit 4 times. Suppose you see here, three times I have given the counter, and it has to stop for 3 seconds. You can change here. You can count 4 times, and it has to stop for 3 seconds. Okay. So you see the animation through the PLC. 1, 2, 3, 4. It stops for 3 seconds. Okay, I can give the flow is less. Instead of 1000, I can give 5. One, 2, 3, 4. It stops for 3 seconds. So like this, I can give a stop time. Timer should be 4 seconds instead of 3 seconds. It stops for 4 seconds. 1, 2, 3, 4. Okay, like this, you can draw any PLC diagram. PLC, you can interface and you can develop any logic, like you try for how the washing machine works, how the washing machine works, and you take these are the output in the washing machine. Otherwise, you can give a bulb here. The outputs are bulb. You can use any number of bulbs here. 1, 2, 3, 4. You can use a bulb. And when this bulb is on, okay, pump is on. When this bulb is on, you can write for first bulb pump, second bulb. Okay, dryer has started in third. Okay, so like this, you can use any number of bulb. You can use any number of sensors. You write a program, you can increase your skill. Knowing the theory of a PLC, how the PLC works, that is usually we are learning a theory in the classroom. But the theory or understanding level is not sufficient. Okay, understanding or knowledge is not sufficient. And parallelly, knowing the things, okay, knowing a C and C++, Java is different. I can write any program and I'll debug. I'll remove the error, then only the skill will increase. A lot of practice is required. It will not come in 1 day, 2 day. You go on practicing more and more, more and more, more and more. You'll come to every time there's a new problem and you are debugging, then once the confidence will increase, you can tell confidently, I have a competency on this software or on this subject. Okay, so like this, this is a freely downloaded software. You can download, even you can how the AND gate and OR gate, it works here. Okay, AND gate and OR gate. You put a one bulb, if both the switches are on, then only the bulb will on. When anyone, this switch is on, the bulb is on, so that you develop any small circuit by using PLC. Nowadays in the industry, everyone is using the PLC, SCADA, and a lot of scope. You see here, suppose if you are good in image processing, I'll talk about the career point of view. I'll talk about career point of view. Okay. I'll stop sharing. Okay. Now, if I talk about career point of view, suppose first I'll start from mechanical. I am good in solar system. Okay, I have done a course on solar system. For example, I have done a course on ANSYS. If you do a course on ANSYS only in the design department, if you go to in the manufacturing department, the ANSYS, they are not using the ANSYS. The mechatronics is like this. If you go to any machine, you go to near to any machine nowadays, piston cylinders, sensors, counters, you take a even electronic PCB manufacturing, any component, suppose registers, they are manufacturing registers, capacitors, anything, the machines are available, the machines are manufacturing the components. If you go to any near to any machine, immediately you can work, okay, controller or which type of PLC, where is the inputs, where is the outputs, what is the logic. Okay, so this is the subject. Day one, you can implement or you can start your career with the mechatronics. So mechatronics is a nowadays very basic subject or a knowledge for an engineer. It may be electrical engineer, it may be instrumentation engineer, it may be chemical engineer, it may be mechanical. Only okay, software engineers, okay, they are also depend upon the application they are learning. Suppose if they are developing a software on PLC, then they should know the PLC hardware, and especially the hardware, the PLC hardware. The actually PLC manufacturing companies, you have a lot of opportunities if you know PLC, how the PLC works and the programming and logic. And not only this, after knowing this software, you should go to the theory of hardware of PLC. What are the types of input models? What are the types of output models? And how the memories, what are the types of memories, how it stores, how it shares the knowledge. And if you go inside, and how to develop the programming for PLC, programming for uh, uh, PLC works, backend programming, whatever I showed, front end programming. So that lot of scope is there. And you take a now in future, you take any product, almost all products should be like mechatronics product in future, so that the lot of features go for all the engineers, so that it is a pandemic and you have a good time. And already yesterday I have given my number today also. I can give my number and my email ID. If you want some more guidance or any problem, whatever I know within that, if you have any problem, please contact me, and definitely I'll help you out. Otherwise, suppose if uh, at least I'll go through, and within 1 or 2 days I can reply. I have given my cell number, and I have given my uh, the Gmail ID. Suppose you want to do some course in some company, and I'll give a company names also. You uh, text me in Mumbai. And luckily you are in Mumbai, so that mechatronics training, lot of mechatronics training companies are available. And one more mail I'll send next Sunday. We are conducting a uh, webinar on mechatronics in our college, through webinar. There is a one company from Thane, so that I'll send an invitation letter. If you want, you can join. You will gain more and more knowledge. So that only thing is that we should not kill the time, and we always worry about knowledge and wisdom, not knowledge. Nowadays there is a wisdom in between, at least knowledge and wisdom. Then only we will grow, and we can serve the nation, we can serve the society. And our responsibility is to not to get the job, and uh, to do the job. Our responsibility is beyond that job, that is serve the nation, serve the society, serve the world. And in the engineering community, we have to take care of our profession. We have to take care of our engineering community, so that nowadays we have to work in interdiscipline. I don't know IoT. I'm hesitate with IoT. I'm hesitate with artificial intelligence. I'm allergic with artificial. You start. Your beginning is very important. I learned this is myself. If you have a passionate to learn, definitely every morning, whenever you will get up, you should think, I have a plenty of time. I should learn something new, not the same thing, something new. Then definitely you are learning. Well, nowadays a lot of YouTubes are available, and Google is available. You have a smartphone, laptop, and even computer. When I was student in 93 to 97, first time I have seen the computer in 93. That is a black and white monitor, as well as very CRT monitor, and a keyboard and floppy drive and all. And nowadays you are so lucky, you are facilities. Only you have to focus. The laser focus is required. And shortly, I'll tell you for laser focus and all, what is my experience. 1 hour you have to do some yoga, otherwise some exercise in the morning. Then only you can control your mind. Otherwise, your mind is always fluctuating, and you will be in the depression and frustration. So that is required. That is a good medicine. So that whenever you will get up 1 hour, half an, you will let us start from 10 minutes, and pranayam. Okay, body is required more oxygen actually. You start with 10 minutes, you see the experience, you see the results, then you go on increasing 10 to 20, 20 to 30, 40, 50, 1 hour. 1 hour is sufficient. Then whole day you can do any magic. So it is my sincere advice, don't kill the time, and go on updating the knowledge. So once again, I'll thank to principal of college, Dr. Murugan sir. He has given me opportunity to share the knowledge. And I grateful to Dr. Gonge sir, HOD of Electronics and Organizing Committee. They are because I'm taking this 8th webinar. They are organized very well, and basically they are focused on students. All the webinars are focusing on the faculty and students, but basically these are focused on the students. That is very appreciable. Thank you, sir. Thank you, one and all. If any questions, please you can ask the questions.
Thank you, sir, for your webinar. Students, if you have any queries, technical queries, non-technical queries, you are free to chat, post your queries on your chat currently.
Even after this also, you can chat to my personal mobile. You can chat now, no issue.
Student was asking regarding the invitation for that upcoming webinar which you had spoken.
Okay, today I'll send. I have all email IDs already. I have taken from you. Today I'll send through mail.
Okay. If there are any other queries, kindly post on chat. Okay, thank you, sir, once again. As we have come to the end of this 3-day webinar series on industrial automation, I request our principal, sir, to deliver a short message to the participants. Mulgun, sir.
Winner, am I audible?
Yes, sir, audible. Yes.
Yes, sir. Yes, sir. In fact, indeed, it was a pleasure having, as well as honor, Dr. Teli, a friend, philosopher, guide, not only in the fraternity of mechanical engineering, though his basic branch of engineering, mechanical engineering, his passion for learning had made mastery not only in mechatronics but also in depth of electronics and communication engineering only. This shows the dedication and the commitment that he has got for the learning. That is how he has been invited by many experts to have a knowledge sharing session, which is his kind heart, for which he accepts and shares the knowledge. Knowledge shares or knowledge sharing doubles the knowledge. This is the principle he has kept. He's rendering his beautiful training session to most of the student fraternity. On behalf of St. John and on my personal behalf, it is my sincere thanks to Dr. Teli for accepting the invitation, and kudos and congratulations for the Department of Electronics. Automation and control is one of the hot cake which is going to be there, because Industry 4.0, we are almost on the threshold of closing from Industry 4.0 and we are moving towards what is called as 5.0, which requires nothing but the applications of this automation and control. So this particular 3-day short workshop has given you exposure what is automation and control. Definitely, as mentioned by Dr. Teli and other well-known speakers, the practice only makes the man perfect. So what you need to do is, in this particular workshop, you are given an exposure, but unless until you try and try to build your logic for the applications of whatever you have learned will going to take you in the far way ahead. It was indeed a nice session. I could not make it from the beginning because of some other assignments which Dr. Tegi has assigned to me. But it was from the feedback. The students as well as fraternity are looking forward for more of his webinars. Definitely, we will also try to have his webinars as well as workshops whenever this particular lockdown eases. We're inviting him, we'll be calling him, and we'll be giving a thorough exposure to all the students who have missed this particular workshop. My heartfelt congratulations to Department of Electronics, the organizers, and the fellow faculty of other polytechnic and engineering college who have made and contributed by the in the form of participations to this particular workshop. I wish a good luck, safety, and stay at home. And we'll be meeting more in the form of webinars and knowledge sharing sessions. Thank you, Dr. Teli. And once again,
Thank you, sir.
congratulations to
Thank you.
everyone who have directly and indirectly participated in this particular workshop. Thank you, and we are looking forward for more association with Dr. Teli. I congratulate Dr. Gongi also for taking the lead, and our diploma, Vishwajit Nikam and Prasad Deshpande, for being the part of this particular webinar and extending invitation to other polytechnic also to take the benefit. So, wishing you all the best. Stay home, stay safe. Thank you.
Thank you, sir, for your message. I now request our HOD, Dr. Gongel, to deliver a short message to the participants.
Good afternoon to one and all. It's my privilege to share with all of you, especially our eminent speakers, the speaker Prathamesh Parab, who make us aware about what are the challenges of the technology which we are not learning in the academic, especially in the printing technologies. So he make us aware about the challenges and opportunities where the aspiring students can have a scope there. From last 2 days, Dr. Teli sir make us what is the need and how the industry can be made automated. And also he has inspired us the scope for the aspiring students, what we can do. Also he have, other than the academics, the sir has given very nice tricks by how to restore the energies and keep your potential at the higher levels. Dear students, audience, these are regular activities. So here, so many forces are always helping us, especially our honorable chairman, our D'Souza sir, our trustee member, Aldrich sir, always giving the freedoms and motivating us to organize such kind of events, whether it is online or offline. Our potential, we have our potential to do anything. This is jointly organized the events by our degree and diploma institutes. But our dealing principles, who always is our driving force, is the who always trigger us or trigger our potential to do the such activities, and he always help us to select the eminent personality like the Teli sirs. So always he is helping us. So his contribution is a lot of in this regard. Friends, from last 3 days, we know it is a rainy season. So many ups and downs are there due to the changes in the atmosphere and the climate changes. Still, my teammates are always hopeful and always fighters, we can say. Even these days, in this period, during this period, they always did very well. So all this energy and potentially got due to the kind supports of our audience, the participants, and our speakers. So really, during this last 1 week, my teammates, especially the winner sir, Sundar sir, Tushar sir, Bibin sir, Subhashini ma'am, Ronald sir, all my teammates are taking very hard efforts to make this program a grand successful. And this pandemic period especially make the knowledgeable to our students and all the participants. So really, it's a appreciative thing to all of them. And especially, I'm very thankful to all the participants for keeping patience and motivating us for the potential energy to my teammates and all the speakers. So hopeful you all are safe. Will you keep yourself in the safe, and best of luck, all of you. Thanks to all of you once more. Thank you. Thank you.
Thank you, Gongel sir. We now have feedback by some of our participants regarding for the webinar. Mr. Vishnu Chandu, can you be online now for the feedback?
CM College of Engineering.
Vishnu, you are muted. Your microphone is muted. Please unmute.
Vishnu? Yes.
Vinod sir, can you unmute?
Hello.
Yeah.
Okay. Thank you. First of all, I should begins by thanking all the entire crew for providing me such a big opportunity to thank such a big panelist or such an important personalities in this section. And really thanks to the SJCEM College of Engineering and Management for providing us such an important platform. And we know the day one, it was 3 days of workshop, and the day one started with the Prathamesh Parab sir, who has given a wonderful introduction or detailed explanation about the importance of automation in flex industries and the opportunities that is put there, that which we can get on that. And the next 2 days was very much safe in the hands of our own Teli sir, who have provided such a good classes throughout the 2 days itself. And it was really valuable, and it was for not only for me, I know it is all the students who have attended food well should have felt the same thing. So thank you so much to the entire crew from my and all other students who have attended the section. Thank you so much, sir. Thank you so much.
Yeah, thank you, Vishnu. If any other participant, if he would like to give the feedback, they're always welcome. If anyone would like to give the feedback now, please unmute your microphone and shoot on. Yeah.
Vinod sir,
Yes, sir.
I would like to add a few lines, please. Huh?
Yeah, sure,
Give me,
sure.
give me 1 minute.
Yeah, sure. Yeah, Gongesh sir, you may.
Sorry to disturb all of you. So I say it is a jointly program. So I have forgotten to mention my dear students. So this is the jointly organized by the degree and diploma institutes. Basically, we have motivated by our diploma students. So they were told me, sir, can we have such kind of program which is we have not studied in the academics. So really, our diploma students motivated us, and they have also contributed to manage all these things, even though they are the diploma level students. But really, their contribution is too much to organize this program. So we should much thanks to them, and our diploma teacher also, we should Nikam sir and Prasad sir. Really, also they have contributed to time with us, and they have did they reached to the maximum students with this pamphlet and everything. So there is their sort of contribution. So on behalf of our teammates and on behalf of them also, I thanks to all of you. Thank you, Vinod sir. Let's continue.
Thank you, sir. I, on behalf of staff and students of SJCM and the entire fraternity, would like to thank all the speakers for taking time from their busy schedules to grace this occasion. We are all inspired as well as enlightened by your session. Thanks once again, Teli sir and Pratmesh. I would like to take this opportunity to place on record a hearty thanks to Mr. Albert W. D'Souza, Mr. Aldrich D'Souza, members of Aldrich Education Trust, Principal Dr. G.V. Mulgul, our HOD Dr. P. Gonge for their support and guidance. And they have extended for the smooth conduction of the series. A sincere and deepest thanks to all the faculty coordinators, Mr. Sundar Karbi, Mr. Tushar Chaudhary, and all other faculty members, EXTC, especially EXTC faculty members, for helping in each and every way possible to make this webinar successful. Special thanks to all our student coordinators for their continuous efforts. And finally, a very big thank you to all my dear participants for being such a wonderful audience and participating in the webinar series. The entire success of this webinar goes out to you. Thank you everyone once again. And thank you, sir, once again. Few instructions for the participants. The feedback link will be provided. The feedback link will be provided just now in the Telegram channel. E-certificates will be mailed to all the participants who have filled the feedback form within 4 to 5 days on their registered email ID. And the presentations will also be shared with the participants after appropriate consent from the speakers. Thank you, everyone. Have a wonderful day ahead.
Sir, sharing the software also, no, to the students.
Yes, sir. I'll send a link, sir. I'll send a software link.
Okay, so that they can build their logic.
Yes, sir. Definitely, I'll send in a Telegram. I'll send a link. You download it and you can practice.
Sure.
Thank you, Teli sir. Thank you, Principal sir.
Okay, thank you, one and all, sir.
Thank you,
Winner sir,
Thank you.
photo session.
I request all of you to just turn on their webcams for a moment so that we can have a screenshot of the session.
Done?
Yeah, done. Thank you.
Thank you, Dr. Teli.
Yes, sir. Sir, I have to tell thank you to you because you have given me the opportunity. Okay, so that you are my mentor and you are my guide and you are my guru, etc., etc. So that I should tell thank you to because my confidence will be increasing.
We have
To
kept all the participants live on Sunday. This thing.
actually, sorry to disturb all the participants on a Sunday. Actually. Okay.
Okay, let us be in touch. Thank you, sir. Thank you.
Okay, sir. Okay.
Once
Thank
more,
you.
thanks to both of you, sir, Principal sir and Teli sir.
Yes, sir.
And
Yes.
congratulations to all the electronics department and
Okay.
Polytechnic wing
Thank
also.
you.
Bonge sir has taken a lot of initiative.
A lot of
Initiative. So because basically sir has focused on students, diploma
Yes.
and degree students. That is a very appreciable thing, sir. Okay, sir. And even organizing team morning there is a problem. They have overcome the problem. Okay.
Some of them they are good.
Good. Okay, sir.
Okay.
The
Okay, sir.
principals have made our team very expert, sir. In any situation, they are the fighters now.
Yes, yes.
Like Indian Army.
Sir has a lot of experience, so the experience
Yes,
matters.
yes.
Okay,
Okay.
thank you. Okay, bye, sir.
Okay, thank you, sir. Thank you. Bye, bye, bye.
Okay, the participants can now leave the meeting.
Winner, sir.
Yeah.
We faculty
Yes.
will be remain in the group. Just have a discussion for 5 minutes.
Okay.
Request to all faculty.
Except EXTC faculty, we request all the participants may kindly leave the group.
Finish, winner?
One second.